There are more and more proof we live in the simulation. We've all heard of collapsing the wave function and the observer effect. The Double Slit Experiment is the definitive experiment that proves you're all living in the simulation, except other than Dr. James Gates. Nobody dared to make that claim, being afraid of being labeled as a quack and have their scientific academia revoked. Welcome, ladies and gentlemen, to an exploration of some of the most fascinating aspects of quantum mechanics and their potential connection to the intriguing idea that we might be living in a simulated reality. Today, we will delve into the concepts of collapsing the wave function, the Double Slit Experiment, the observer effect, and how they fit into this thought-provoking hypothesis. Our journey begins with the foundational principles of quantum mechanics. In the quantum realm, particles like electrons and photons are not just particles but also exhibit wave-like behavior. This duality forms the basis of the wave-particle duality principle. When not observed, these particles exist in a probabilistic state described by a wave function. The wave function represents the range of possibilities for a particle's position, momentum, or other properties.
Now, let's discuss the concept of collapsing the wave function. When a quantum system is observed, its wave function collapses to a single, definite state. In simple terms, observation forces particles to choose a specific outcome. This phenomenon baffled early quantum physicists and gave rise to the famous Schrödinger's cat paradox. So, how does this relate to our potential existence in a simulation? To understand this, we turn to the Double Slit Experiment. In this experiment, a stream of particles, like electrons or photons, is fired at a barrier with two slits. Behind this barrier, there's a screen where these particles are detected. Remarkably, when particles are not observed, they exhibit an interference pattern on the screen, much like waves. However, when observed, they behave as discrete particles, leaving a pattern that resembles two distinct slits. This peculiar behavior raises important questions about the nature of reality.
The observer effect is central to our discussion. It suggests that the act of observation influences the outcome. It forces the quantum system to choose a particular state. This phenomenon implies that the observer plays a significant role in the reality we perceive. But how does this connect to the simulation Dr. Kusanagi mentioned? Your take on this matter is quite intriguing. If atoms can behave like waves, then the idea that all matter consists of waves becomes compelling. You posit that this entire universe could be a holographic projection from a more fundamental, objective reality beyond our comprehension. In this scenario, all matter and energy in our universe would be akin to pixels in a vast cosmic simulation. The physicist Michio Kaku has raised a valid point regarding the simulation hypothesis. He argued that the universe is fundamentally quantum mechanical, not binary.
Reality as we knew it was all wrong. Is that possible? Well, the answer is probably no, but for a very sophisticated reason. Life is quantum mechanical. Life is not based on zeros and ones. Photosynthesis, for example, is a quantum mechanical process. It is the basis of all life on the earth, and we still don't know quite how it works. A flower can do calculations that our most advanced quantum computer cannot. Amazing, truly amazing.
This assertion initially seemed to challenge the idea of a simulated universe. However, as you suggested, he may have inadvertently supported the hypothesis. A super advanced quantum computer could simulate a universe based on quantum mechanics, thus aligning with Kaku's observations. However, Kaku is wrong about the following statement. The only thing that can simulate the weather is the weather itself. He talks about the advanced rotation and forces acting on the air. If in the case of classical computing, it would be impossible to simulate down to the atom to simulate just the weather. He is wrong, because in modern gaming as we know today, a game such as GTA 5, the game does not need to simulate or render that, which is not being observed. And if atoms are not being observed, Why does it need to be rendered?
Whatever is running all of this has enormous processing power. But these glitches that we see, like the Mandela Effect, show me that it has its limits. If this structure is a simulated structure, the sim need only be concerned with the walls, the shadows, the glass, the reflections in the glass.
That's procedural generation. I mean, we use that in video games.
It's not wasting any power or any energy on what's inside the building. Not until someone has the intention to walk in there.
If a tree falls and there's no one around to see it, does it make a sound? Does it even exist at all? What about the forest itself? You think this world works that way, that when we're not observing it, it's saving data?
It's my belief that our observation contributes to the creation of the physical world, yes.
If a conscious being isn't observing something, does that thing actually exist? In computing, in video games, procedural generation allows a computer to not get bogged down in processing data that it isn't using or observing. If something isn't being observed by the collective consciousness, then it would cease to exist until it is observed once again. If the computer that was running the simulation had unlimited power, it wouldn't need to conserve bandwidth like that. If we could access the code, it could be crashed.
That's my hypothesis.
So, if we consider that we are living in a simulated reality, it poses profound questions about the nature of our existence. Does our observation actually serve as an integral part of the simulation process, as the observer effect implies? Or maybe, just like playing The Sims 4, does the sim you play that runoff on auto mode living its life also experience the observer effect? Imagine your Sim's character just runs on auto mode, believing where it is. Is base reality? Your sim decides to become a game developer. It wants to make a simulation as real and as indistinguishable from reality as possible. It goes to SimVidya and buys the latest RTX 4090 and understands how ray tracing works, sending a beam of light into virtual space as it bounces and creating ambient occlusions and so forth, the most realistic lighting. However, your sim character comes across the Double Slit Experiment and decides to run an experiment of its own. Your sim grabs a focused small point of a powerful flashlight and casts the light into a dark room with objects with different reflective surfaces. The sim suddenly noticed the beam of light upon hitting an object behaves exactly the same as how the SimVidya RTX 4090 works in her video game that she just made. And the sim sat down and says, "Oh my god, I'm in a simulation."
The CERN Super Collider is dangerous. The first beam will circulate on 10 September 2008. The first spottings of the Mandela Effect online that I can find is also 2008.
Physicality also changes based on an observer to observe, which in layman's terms means that it exists in more than one place at one time.
Parallel worlds overlap with ours. And if we're smart enough, we can dive into them and grab their resources and pull them back into ours.
Are you saying that your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computer?
That is correct. And what I've come to understand is that there are these incredible pictures. Buried in them are computer codes that contain all the information of a set of equations that are related to string theory. And so I'm left with the puzzle of trying to figure out whether I live in the matrix or not.
And what does string theory say? It says that there is a multiverse. If there are other universes, can we go between universes?
Thank you for joining me on this journey through the quantum and metaphysical realms. Remember, whether our universe is a simulation or not, the skills we learn here is what is real here in this simulation.